Okay, today I'm going to debrief the Unit 2 Quiz 1. It's all about the atoms and its interaction with energy. Here's the most missed question. What element is an atom that has 14 protons, 16 neutrons, and 15 electrons? So to know what element an atom is, you need to know the atomic number. In other words, you need to know its number of protons. So we actually need to just look at right here, number 14. There are 14 protons, so atomic number is 14. Take a look at the periodic table. Atomic number 14 is silicon, and that's it. Alright, that's the answer right there, silicon. Second question now. What does it mean to know the atomic mass of carbon? So, what's the definition of atomic mass? The definition of atomic mass is it's basically the average mass of all of the isotopes of that element, considering the percent abundance of each of those isotopes. So which one of these matches that? It is the exact mass of every single carbon atom that exists in the universe? No, that can't be possible. It is the mass of the most common isotope. Nope, it's the average, the weighted average of all of the isotopes, right? It is the weighted average of all of the different masses of isotopes of carbon that accounts for the relative abundances in nature. That's the one. Okay, it has to account for the relative abundance, because the one that there's more abundant isotopes of, that one should contribute more to the atomic mass of that element. And then just the last one, it is the average mass of all the different masses of all isotopes of carbon. Not just the average mass, has to account for the percent abundances, so it's the weighted average mass. Okay, it's super important. Alright, next question. You find that a sample of chlorine atoms actually have a net charge of -1. How many electrons must be in each of the chlorine atoms? Okay, so chlorine atom. Okay, we got a chlorine atom. It has a net charge of -1. Okay, well, if it has a net charge of -1, that means there should be more electrons than protons, right? There's gotta be more electrons than protons, more negative things than there are positive things. Okay, well, do we know how many protons there is in chlorine? We should be able to figure that out, because chlorine's identity means that it has a certain number of protons. Chlorine specifically has 17 protons, according to the periodic table. So if we know that there are 17 protons, how many electrons are there? Well, we know that there has to be one more electron than there is protons, right, to have a net charge of -1. So that means one more than 17 has to be 18. There's got to be 18 electrons here. Okay? Next question. Let's see what we got. In a Bohr model drawing, what are the orbits that are around the nucleus known as? So in a Bohr model, this is, you just gotta, oops, my mistake. You just gotta have, like, let's say it's boron. You just gotta know what Bohr models represent, right? So just look at the very last reading for this unit that we've had so far on Bohr models, and it'll tell you that these orbits are called energy levels. Okay, so it's kind of like a definition thing. Do you know the definition of energy level? It's what the little orbits are in a Bohr model. Alright, next question. How many energy levels are there in a helium atom? Well, we know they're the orbits, right? And based on the activity that we've done, to know how many energy levels there are, we need to look at the periodic table, right? Remember that pattern that we were seeing with the activity? Okay. On the periodic table, helium is actually right here. Okay. To know how many orbits or energy levels there are, you just gotta look at which row it's in. If it's in the very first row, all first row elements, meaning hydrogen and helium, have to have just one energy level. Okay. If it's in the second row, it should have 2 energy levels. If it's in the third row, it should have 3, so on and so forth, as we should have discovered in the activity. So since we are talking about helium, and helium is on the first row, the first period of the periodic table, then helium should have 1 energy level. Our next question has this giant diagram of the Bohr model. Okay, so according to the Bohr model of hydrogen atoms shown, how many visible colors of light would the atomic spectra of hydrogen have? Okay, so there's a lot of different forms of light. The only ones that we can see, they're called visible light. And if you were paying attention in class, or if you just notice right here where it says visible, there should be a certain number of wavelengths that is released from the atom. So this one is if, the electron drops from the 6th energy level to the 2nd energy level, that would emit a certain color. That color would be whatever 410 nanometers is. Okay, I don't know what it is on the top of my head. I think it's purple. But this one is just asking about, how many colors of light would you see? Well, just count how many wavelengths, right? Because color is the same thing as wavelengths. So here's 1, here's 2, here's 3, here's 4. We're just looking at the ones underneath visible. Okay, so there's 4 colors of light. And we've seen the emission spectrum of hydrogen through that picture. Unfortunately, we didn't see it in class, but we saw it through the picture, right? There's 4 colors. There's blue, there's purple, there's a teal, and then there's like that orange-red color. So there's 4 colors. Let's take a look at the next question. For this next question is asking, what is the correct depiction of the Bohr model of a sodium atom? Now, we need to know how many energy levels there are in sodium, but sodium is Na, by the way. And then, how many energy levels are there, right? How many circles are there? Well, to know that, you have to look at the periodic table and find sodium. Well, sodium is right here. It's in the 3rd period, the 3rd row, meaning there should be 3 energy levels. So, what would that look like? Yeah, it would look kind of like that, right? 3 orbits. How many electrons now? How many electrons do we put here? Well, according to the periodic table, let's see, sodium has an atomic number 11, meaning there's 11 protons, but since this is an atom that we're talking about, atoms are neutral. There should be the same number of electrons as protons. So there is 11 electrons as well, right? 11 electrons. So here we go. The way we put the electrons is, well, the first energy level can only have 2. You do it kind of like that. The second level has up to 8, but you have to make sure you fill in the 4 spaces first, and then you start pairing them up. So we got 6 so far, and then 7, 8, 9, 10. Alright? So now the second energy level has 8, kind of like the pattern that we saw in the activity. We have 10 so far. Where does the 11th one go? It goes anywhere on the 3rd orbit. Okay, 3rd energy level. So which one does this look like? It should look like this one right here. Okay, so that one's the answer. It should have 3 energy levels. It should have 11 electrons. The first energy level can only have 2. The second energy level can have 8. And then that means the last energy level has that one last one, so that the total number of electrons is 11. Okay, let's take a look at the next question. What do we have here? What happens to an atom once an excited state electron falls to a lower energy level? This is how atoms interact with energy. So when an atom starts off, it has an electron that's at ground state. Okay, this is called a ground state electron. But when it absorbs energy, it jumps up to another energy level. It jumps up to the second energy level. Now it's an excited state electron. Well, that's how it absorbs energy. What happens when that electron falls back down? So once it falls back down, where does the energy go? Well, it's released back to the environment, and it's released as light. Okay, that's how it's interacting with energy. So an atom has electrons. Those electrons, when it goes from a ground state electron, a ground state energy level, it can absorb energy, and then the electron goes up to a higher energy level. And then the opposite is true. when the electron falls to a lower energy level, it releases that energy, and it's released in the form of light. Okay? It's really one or the other. It absorbs energy or it loses energy. So it would be this one right here. The atom releases energy in the form of light. Okay, next question. There are 3 isotopes of boron. Boron 10 has a percent abundance of 49.28%, boron 11 has a percent abundance of 20.44%, and boron 12 has a percent abundance of 30.28%. Which calculation below would calculate the atomic mass of boron? So for atomic mass calculations, or average atomic mass calculations, you're basically taking the atomic mass units of each isotope. So in this case it would be 10, 11, and 12. And then you're going to multiply by its relative abundance. And then add them all up together. So the only possibilities would be this one or this one, right? So in each of them, we have the atomic mass units, 10, 11, and 12, so that's good. But which one is multiplied by their relative abundance? Okay, the second one is multiplied by the percent abundance. That's what it says in each of the questions. It tells you the percent abundance of each of these isotopes. So this one doesn't have relative abundance, it has percent abundance. We need to multiply it by the relative abundance. And relative abundance is when you take the percent abundance and then you basically divide it by 100, okay? So what does that mean? That means that, okay, right here we have, instead of 49.28%, we have 0.4928. That's the relative abundance. And then for the next one, we have, instead of 20.44%, we have 0.2044. That's the relative abundance. And lastly, instead of 30.28%, you have 0.3028. That's the relative abundance. It's basically taking the decimal form of the percentage. Okay, so the answer would be the one that has relative abundance multiplied by the atomic masses. Sorry, the isotope masses of each isotope. Next question. Determine how many neutrons there are in a strontium-25 atom. Okay, so strontium-25, this is the mass number right here. And mass number is protons plus neutrons, right? So, do we know anything about this? Well, sodium. If we know it's sodium, we can figure out its atomic number. And if we know its atomic number, we can figure out how many protons there are. So if we look in the periodic table, we find sodium again. Atomic number 11 means there's 11 protons. So there is 11 protons. We know that you add a certain amount of neutrons, and that will give you your mass number, right? 25. So 11 plus something is equal to 25. What does that something have to be? 14. 14, right? Okay, next question. There are 4 isotopes of sulfur: sulfur-32, sulfur-33, and sulfur-34, and sulfur-36. Which isotope of sulfur would be the most abundant on Earth? Seems like there's not enough information here, but remember, you have a periodic table. According to the periodic table, if you look at sulfur, it has a average atomic mass of 32.06. Okay, and remember, average atomic mass, it accounts for, or it's closer to whatever isotope has the most abundant form, right? So if we know that the average atomic mass accounts for, the highest percent abundance isotope weight, then that means the isotope here that contributes the most to the average atomic mass should be the one that's closer to the average atomic mass. It should be sulfur-32, and that would be it. Alright? Okay, next question. What do we have here? Okay, it's reading, the identity of an element is determined by Well, atomic number is associated to the element's identity, right? Atomic number determines how many, what's the element's identity. But if you read it, nothing says atomic number. What is it then? Well, what is also the same as atomic number? Always. The number of protons. So, in essence, since atomic number determines identity and protons is the same as atomic number, then how many protons there are in an atom will tell you the identity of an element. Let's see, next question. How does an atom get a net charge to become an ion? So in an atom, there's three subatomic particles, right? There's the protons, there's the neutrons, and then there's the electrons. And we should know protons are positive, neutrons, they're neutral, they have no charge, and then electrons, they're negative. For an atom, which has a specific number of protons, to get a charge, right, you gotta have an imbalance of positive and negative things. So, for example, if you have 10 protons and you have 10 electrons, it doesn't matter whatever the neutron count is. If there's 10 protons and there's 10 electrons, that means there's 10 positive charges and 10 negative charges. That means in total, like in the net charge, it would be 0 because the 10 positives cancel out with the 10 negatives. Only when you have a difference of protons and electrons will there be a net charge. So now if you have more electrons than there are protons, then your net charge should be negative. There would be a -1 in this case, right? The same would be true if there's more protons than there are electrons. If there's more positives than there are negatives, then there should be a positive net charge. So if you think about that, an atom becomes an ion, or an atom becomes charged, when there's a difference in the number of protons and electrons. So which one would that be in this question? It would be the first choice, when the number of protons and electrons in an atom are different. Excellent. Alright, let's move on to the next question. Why does the mass number of an atom not include the mass of electrons? Right? Mass number is equal to protons plus neutrons. Have you ever thought about why? Why doesn't it include the electron? The electron is part of the atom, right? Well, if you read from the reading, you should know the relative size of protons, neutrons, and electrons. Protons and neutrons, they are about the same mass as each other. So we would give them an atomic mass unit of 1. For a proton, it's 1. For a neutron, it's 1. What about an electron? An electron is actually incredibly tiny. Hopefully I emphasized this enough, or you at least saw it once in the reading. Electrons are super, super tiny, meaning like the mass of an electron, if it's that tiny, it's negligible. You can say that an electron has no mass, because in comparison to a proton or a neutron, proton and a neutron is ginormous compared to an electron, right? So that's the reason. Let's see. That would be the last one right there. The mass of electrons are so small. Oh, why does it say small, small? Well, typo. The mass of electrons are small, small compared to protons and neutrons, that it is negligible. Okay, it's supposed to say so small. Next question. Let's see, what do we got? What does it mean for an electron to be in an excited state? Oh, I described it earlier. When an electron from ground state absorbs energy, it jumps up to a higher energy level, right? Anything to associate with that, right? So let's read through these choices. The electron absorbs more energy and becomes oppositely charged? No. The electron absorbs more energy and now has a bigger negative charge? No. The electron absorbs more energy and is on a higher energy level. That's it. That's an excited state electron. Next question. How many electrons are there on the outermost energy level of a fluorine atom? Hint, draw it first. So fluorine atom, actually we drew this before. How many energy levels are there? Let's see. Fluorine on the periodic table is in the second row, second period. There's 2 energy levels. 2 energy levels. So let's see. First, second. How many electrons are we going to draw on this atom? Well, fluorine has an atomic number of 9 protons. Since this is an atom, there should be the same amount of electrons, 9 electrons. So we're going to draw 9 electrons here. First energy level can only hold 2. Second energy level can hold up to 8, but we're going to probably not have completed it. So here we go. 1, 2, or 3, 4. I meant to count like 5, starting from 2. So let's redo that. So I have 2 so far. 3, 4, 5, 6. And then once each side has 1, 7, 8, 9. Alright, there we go. So, the question is asking the outermost energy level, right? The outermost energy level, that would be this one right here. How many electrons are there? 1, 2, 3, 4, 5, 6, 7. There we go. 7 electrons on the outermost energy level. That's actually really important. It has to do everything with bonding, which we will learn about later. So it's important to know how to identify how many electrons are on the outermost energy level. Okay, next question. Which of the following best describes what a neutron is? Oh, I actually kind of described this earlier. Neutron is one of the 3 subatomic particles in an atom. It has a mass. It weighs about the same as a proton, but is way, 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 way bigger than an electron. Okay, an electron pretty much has no mass. And also, a neutron does not have a charge. So what fits that description? Let's read this. A particle around a nucleus. Nope, it's actually in the nucleus, so it can't be the first one. A particle around a nucleus. Nope. A particle in the nucleus. Okay, that sounds more right. A particle in the nucleus of an atom that has a mass but does not have a charge. That's it. Okay, next question. Let's see. The mass number of an atom is based on the number of, well, this one's just definition. Mass number is protons plus neutrons. Protons plus neutrons. And then we got this next question that has these 2 big graphics that we talked about before. Use the figures below to help you figure out the wavelength of light the atom would release or emit if the color was blue. So, I mean, we got these choices right here. Which one is it? Which one is blue? 656 nanometers. That would be, that's 20, 40, 60. 656 would be around here, right? That's not blue. Next one, 1282 nanometers. That's not even on this chart. So technically, it's way past the wavelength of light, and it would actually be 1282. What the heck? 1282. Oh, maybe we can use this. 1282. It says it right here. That's actually infrared light, so we can't see that. So it's not that one either. Let's look at the next one. Is it 94 nanometers? 94 nanometers. It's not even on this chart, right? That's not even a color of light that we can see. 94 nanometers is on the left figure. It's part of the ultraviolet spectrum, so we can't see that either. And then 434 nanometers is probably that one, so let's check. 4, and this one's 420. This one's 440, so 430 would be around here. Ah, that one's probably blue, right? 434 nanometers. That's how we can do it. Okay. Oh, this is the very last question. Here we go. What is the atomic... Oops, my mistake. What is the atomic mass of zinc in atomic mass units? Atomic mass, or average atomic mass, same thing. You can find it on the periodic table. So we're going to find zinc. Where is zinc? It's right here. Atomic number 30, meaning it has 30 protons, but we're looking for atomic mass, which is the bottom number, 65.38 atomic mass units. Here it is. Alright, hope you found this helpful. If you feel like you're comfortable, then you can do the retake now. If you feel like you need more help, you can ask me for help. I'll walk you through it. And then hopefully you'll feel more successful then to do your retake and improve your grade.